Hello, I'm Eric Snodgrass, and thank you for watching today's Ag Forecast brought to you by Nutrien Ag Solutions. I want to look back over the last 15 days to try to understand how this pattern evolved that we're dealing with now as we get into the middle part of June. So we're looking at temperature anomalies here. And when we look back over the last 15 days, we do see the much below normal temperatures that have hit parts of Texas and the Mid-South, getting over to the Southeast. A lot of cloud cover and a whole lot of precipitation. To the north of that, in through this wedge, in through here, and even backing up to the west, we've seen some pretty extreme heat so far. And my big question is, what has that done to kind of the net position of the jet stream? So we're going to go look at it. 300 millibars zonal winds, that would mean west to east, and this would be from the 1st through the 12th. Now, when you look at it, where we see the blues, that would mean where the atmosphere is moving more north-south, and the warmer colors represent more west to east. And what this, in effect, tells us is that the jet stream really pushed pretty far to the north here across much of North America. And there was an interesting setup happening here just off the Aleutian Islands. We're going to talk more about that in a few moments. There was a cutoff low that was just to the south here that slowly moved. This is what brought in all those soaking rains through this area. In fact, let's go take a better look at it by looking at anomalous flow at the jet stream level. So what we see here is there's a rather large anticyclone sitting just south of the Aleutian Islands. Then you can see kind of the net position of the jet stream here. But there is a sense of circulation right there, and that is that cutoff low that was underneath the main flow that has just brought soaking rains through parts of the Mid-South, the lower Mississippi River Valley, over into the Mid-Atlantic and the Carolinas. And to see all of that, this would be the June 1st through June 14th total precipitation ranks by climate district. And there are several districts into parts of Arkansas and Mississippi and surrounding areas that are not only having their wettest start to the month of June, but several of the surrounding areas are top 5 to top 10. We've erased drought concerns over in parts of the Carolinas, given the incredibly heavy rains as of late. But again, that's going to be a temporary, fix on the drought that's in this area. But for many of you, I'm sure your eyes are drawn to this very large region in through here where we have had extremely dry weather to start the month of June. It's also been dry in pockets in the Northeast as well. Just focusing in on Iowa, I've been getting a lot of questions about rains returning to Iowa. Just to make a point here, this is like a top 5, top 7 driest starts to June on record. That goes back 129 years. There have been better storms in North Dakota and even coming out of parts of Montana, especially this northeast corner of Montana. But as this pattern sets up and adjusts a little bit, we need to see how precipitation works its way back into these areas to help revive some of the fields in these very, very dry locations. So another way to look at this is just to look at the last 14 days in terms of percent of normal. And I put this up here to kind of put into context some of the rain that just came through. So for example, my home state of Illinois, you do see these scattering here of getting out to where we're at 100 to maybe up to 200% of normal, but it's very scattered precipitation. Just as a case in point, I live right over here in a little town called Mahomet. And where my rain gauge sits outside, I got 1.6 inches, but not a half mile away, one of these storms only put down about 0.7 inches. So this is widely scattered storms. Now the cutoff low farther to the south, which is we're still getting the effects of it here in the Northeast. There were places in through parts of Arkansas, Mississippi, over in Alabama that saw over 1,000% of normal. My color bar only was up to 325, by the way. So this was over 1,000, and we were between 800 and 1,000% here. There's been flooding in the Mid-Atlantic. But I want to come back to this region in through here, because a lot of these fields were missed by some of the storms that went rolling through here. And when we think about that, it also makes us think about some of the deeper problems we have with soil moisture. I would also like to point out, when you get over into the eastern half of the Snake River Valley, get into the Columbia Basin, extremely dry, while some of the nearby areas have been much wetter as of late. Now, last 7 days of total accumulated precipitation, we looked at this a lot last week, but let's just get an update here. And again, we see in parts of the central and western Cornbelt, there are a lot of holes in here. And get over to parts of the plains, it was dry. And down in southern Texas, it was dry as well. So just map to add context to the conversation we've been having. Now, last week on Thursday, they did release the new drought monitor, and this is what it looks like. But this only had data in it through June the 8th. Remember, the data goes through the Tuesday of that week, and the map is released on the Thursday of every week. And as I've been doing, and I'd like to do this again, I'm going to show you a change map. And let's just look back over the last month. Now, as we have seen lately, some of this drought is going to go away in the next update with all the heavy precipitation that's come through. But most of the other regions in through here, I don't expect too big of a change when we get our newest monitor coming out later on this week. And I think the story is kind of finished being told by looking at soil moisture and change. So this would be the top 16 inches or 40 centimeters back at the end of May. I picked May 27th. That seemed to be right about the peak of the drought issues we were having over in the Mid-Atlantic. What has changed since then? Well, this is the new map valid for today. If I go back and forth, this is the 27th, and here is the latest data we have now. So that cutoff low has produced flooding in this area, but has also reduced the drought. The concern now becomes, let's try that again, right in through this area. That's a large region where we have yet to return quite a bit of moisture. So let's get into a forecast and kind of see where this is all going. I was watching some satellite imagery. In fact, I want to take you back to yesterday really quickly, because this was just as the sun was setting last night, and you can see a lot of haze. There are actually several fires that from the Intermountain West and the Great Basin that's putting smoke into the atmosphere. And as the sun was setting, some of these storms that were coming out of the high plains here, Colorado, Nebraska especially, but getting up into South Dakota, these were some hailers, putting out some big hail and some locally heavy rainfall. In the overnight hours, as they kind of collapsed and slowly started to fizzle, what we ended up getting out of them is just the leftover anvil. So that's the upper level cloud that's pushed out deep into the atmosphere, and it was spreading across parts of Iowa early this morning. And then as we get right here to the end of the loop, which would be valid just as I was recording this right around noon, you can see that what was left of those storms has really kind of fizzled out. Now, we did see something still pushing through central Texas, some bigger storms this morning right into this area. But as I was looking at this image, I was looking a lot at the fires, and then I noticed something right here in northern Illinois. In fact, let me show you something about this. If I go to the localized sectors and click right here, you can see the fire that is, I'm going backward in time here. Here it is. This is early this morning, and the smoke from that fire pushing pretty far to the south. Maybe we can see some of that smoke from like the LaSalle, Peru area. But this was a fire near, I believe it was in Rockton, Illinois. A chemical plant fire. I'll have to go back and look that up. But you can see how dark that smoke is. Now you can notice that it's coming out of the north, and that's because right now in the low levels we do have a wind coming from this direction. It has brought in some drier air into this area after a very hot and humid weekend before the atmosphere really popped. But since we're looking here at this low-level flow, we better talk about what's right here in the Bay of Campeche. This was something we talked about last week as being an influencer on this week's precipitation pattern as a tropical disturbance likely moves in this direction. But before I give you the details on that, I just would like to show you the upper-level flow. So this is about 500 millibars right now. And you can see that the net flow is building into a large ridge centered over Montana. We need to ask ourselves, is this ridge blocked or is it open and is going to move, because that will be critical to this upcoming pattern. So let's get through all of that, okay? National Hurricane Center, this is their 5-day graphic. They just updated this morning at 8 a.m. and bumped this up to a 60% chance of cyclone formation. We did have the formation of Tropical Depression number 2, but this is going to be going on off out into the open ocean, producing some very windy conditions and some big waves, but it's out there. And there is another system we're going to watch. It's got a 20% chance of development through the next 5 days, but there are waves coming off of Western Africa, and we're in that time of year that we got to be paying close attention to what these waves could eventually become. Now, in the near term, this is the one I want to watch. And the reason why is because the ECMWF in the ensemble gives it about better than a 70% chance of developing into a tropical depression. Now, what we've always been concerned about is how the moisture from this spreads to the north, how far to the north and west it makes it, and then what does it do as it moves over some very saturated soil into those areas. Because right now, the early morning runs here from the European model, and the European 12Z is just not even going yet, or not out yet, does keep the ensemble tracks doing something like that. And the GFS has a little bit different version of this, and we're going to take a look at why those are different here in just a few moments. First, this is the latest update for where we're on the lookout for some severe weather today. So in parts of the high plains, along the Gulf Coast, storms down here. But it's going to be in parts of Pennsylvania through New Jersey, clipping parts of Maryland and Northern Virginia that we're going to watch out for some stronger storms later today. And to take a look at that, why don't we go look at there it is, brand new high-res model from the NAM. We'll blow this up so we can see it a little bit better too. So as we get through middle of the day, so this is about the time I'm recording here, you can see there is a low that is slowly spinning its way here into parts of the northeast, out of Ontario into Quebec and then the northeast. So the concern is there could be isolated storms in this area that produce hail, strong straight line winds, and possibly even isolated tornadoes. There's a frontal boundary to the south. You see it here. And on that, we could get some scattered showers and storms too. And then as I play this on through, I'm just going to rock back real quick. Do notice in the Pacific Northwest, the flow out of the south-southwest is going to push some precip here over into parts of eastern Washington. And there are areas in here that over the last almost 6 weeks are having record dryness over the last 130 years. All right, so let's now play through Tuesday. Here we are midday tomorrow on Tuesday. Work on our way into Tuesday evening. And again, there's still going to be some scattered storms along the Gulf Coast. And as that system exits in the northeast, some scattered storms there as well. But then as we get out into the overnight hours and early on Wednesday, this is where we start to see the next few pieces coming together. You can see that right in through here, maybe some scattered storms, but the broader implications of the moisture surge coming into the Gulf of Mexico is what we really want to be talking about, because that's going to be coming in under this ridge. Now, last week when we were watching this and discussing the position of this ridge and what it was doing, my most indications that I had was that this particular ridge, while not blocked off, all right, it is an open wave, all right, it's not like a Rex block or a high over low or an omega, it is an open wave. There was some concern that it was just going to continue to push that jet stream north. And even though there was a little trough that was going to dig on the other side of it, didn't seem it was going to be digging quite as deep as it did. So as we go through the day Monday into Tuesday, that's the wave that comes through and keeps the showers going here into this part of Oregon, Idaho, and Washington. And the wave, the big ridge out ahead of it, look at that. That's going to put in some pretty serious heat. But then what happens is because this wasn't blocked off, that shortwave kicks through here into the Canadian prairie, and it eventually helps create a system later on this week that dives over here into parts of Ontario, eventually through the Great Lakes, and then pushes over here toward the north and east. And this is just something to remember about the jet stream. I'm just going to trace it for us real quick. And what I want you to remember is that the position of the polar jet stream is such that underneath it is where we have our strongest low-level temperature gradient. In fact, that's what makes the jet stream in the first place. And so by this weekend, we need to be watching out in this area for some sort of frontal boundary. And on that frontal boundary, if we're pushing all that moisture from the tropics into it, what could that do in terms of creating some precipitation over some very dry locations? As we get out there farther, what ends up happening is the jet stream goes very far to the north in the Gulf of Alaska before diving down like this. And therefore, I do expect quite a bit of heat to build up the west coast, while we'll get some breaks from the cooler weather as we push out there toward the solstice, which would be Monday the 21st. Okay, with that all set up, let me just shrink this up a little bit right there. There we can see it all. This is the next 5 days according to the European model. And I just want to point out a couple of things. First system exits here in the next couple of days. We watch the tropical moisture come in out of the Bay of Campeche. And here's the beginning of that front that's going to set up. So we're going to watch later on this week for storms right in through here. What you have in the Pacific Northwest is coming in the next 36 hours. And after that, it is going to go dry in that area. All right. From there, let's jump out to day 5 through 10. This is the 0Z ECMWF. Now the flow is going to come down like this in the jet stream. That will push against the mountains and produce precipitation there. But there will be a frontal boundary draped somewhere in this vicinity, kind of like Nebraska to Iowa. And the tropical moisture from the system to the south will push into that. Now how this frontal boundary establishes itself late this week, I mean this is still 5 days away, and then into early next week we'll determine how much rainfall is going to fall into this area. But you can see that everything kind of gathers and pushes itself into this direction, returning rain over to parts of the very saturated fields of North Carolina, and also quite a bit of moisture down here where there is still ongoing flooding in that area. The west under that ridge gets hot and dry. All right. So I think the best way to look for this is to do that same thing we did last week, and let's compare the model runs. This is the trough ridge pattern. So there's the large ridge. Both models agree on that being in place by Tuesday, and I'll show you the heat that's going to come with this in a few moments. But as we play it forward, let's get out here toward Wednesday, and then how about Thursday? Let's stop at Thursday morning. Now, there are some key differences at this point, although it doesn't look like it, there are, and it has to do with the wave that's right here. The GFS in this position, the European there. Now, as we go from Thursday into Friday and then eventually into Saturday. Let's just stop it right there, Saturday in the morning. What I want you to notice is that the European model has a deeper wave farther to the south. The GFS has a short wave here, the main trough there, and another short wave in through this area. It's more farther to the north, which means that the European model run is going to put a front farther to the south in this area, whereas the GFS will likely keep it weaker and farther to the north. And I'm going to show you what that means in a few moments. But as we play this on through Sunday into Monday, here's the other part that's quite different. The European model keeps this wave on a positive tilt, whereas the GFS flings the next wave through. I don't know if that's a technical term, but kind of pushes it on through, gets it almost standing north-south, and then eventually gives it some negative tilt. The net effect of this will be to produce a low-pressure system that'll ride that front in the European, and possibly not quite the same intensity of a front that's going to be on the GFS. Now, beyond this, both models try to produce a pretty sizable ridge just off the west coast, and that's going to help things heat up. But the differences are important, and I want to show you what they look like. So let's wander through these maps together here and see how this all plays out. We've seen through Monday and into Tuesday, so we've already got this idea down. There's the high pressure that comes in by Wednesday, so we've anticipated that. Now, the upper level low that by Thursday goes through the Canadian Prairie is positioned here. In fact, it's north of the Canadian Prairie, and both models have that. And what is interesting is the interaction between that low by the time we get to Friday. Let's just park this here Friday morning, and the tropical system. So you can see in the GFS, most of the moisture is on this side of this tropical system, whereas in the European, the low is still here, and it's brought more of that moisture around its kind of northeast side. Now, there's a lot of differences in the flow between about 850 and 500 millibars. That's going to help the European keep the moisture farther west and the GFS keep it farther to the east. But at the same time, as this this northern low goes through the Hudson Bay and the frontal boundary comes in like this, watch the difference between the GFS, which I just drew on, and the European, okay? Because going out, this is now Friday morning, afternoon, and evening, getting into early Saturday morning there, Saturday midday, Saturday evening. Now we get into the weekend. Now notice the difference here. The GFS puts the rain from the tropical system from Alabama, really Mississippi, Alabama, Georgia. The European has it here. The European has a much more defined frontal boundary that goes all the way up into Montana, and you don't see that in the GFS. And as we continue to play this forward, the European breaks out a low here that then pulls that moisture to the north of it right into this area, bringing a lot of rain to Iowa, Illinois, Wisconsin. And this is an area right in through here that desperately needs this rainfall. It's not showing up Sunday afternoon in the GFS yet. Then as we go through, this is now getting out there through early Monday morning. Notice how much more aggressive the European is with rainfall in this whole area, interacting with the tropical system, which in the GFS is farther to the east and separate. So there's a weak low moving through Wisconsin in the GFS, but it's entirely different in the timing and strength than what we've got over here in the European. And that takes us all the way out to next Monday. So to kind of summarize all of this, we're going to look at it like this. I made that map for you like I did last week, and what it shows you is the difference between the GFS and the European. We're comparing 0Z runs. The European is much wetter from parts of Montana through the Dakotas, getting into Iowa, Illinois, into Michigan as well. The European also has the tropical moisture farther to the west, whereas the GFS, which is shown in these colors as being wetter, is much farther to the east. So again, when you look at this, these colors represent where the GFS is wetter, and these colors represent where the European is wetter. So if I were farming in Iowa right now, I would be rooting for the I would be rooting for the European, given what it is doing with that boundary. Now, I will be honest, this is going to change a lot this week. And we've already got the 12Z GFS in. I was just analyzing before this video. It continued what the 0Z and the 6Z did. But we need to see how the model runs continue to handle this very important Cornbelt precipitation moving forward. And that's why I'll look forward to giving you those morning updates if you're on my daily subscription list, and also another video update on Thursday. From there, if we buy into the European model solution on this, this is that volumetric soil moisture data. We know how dry we are in places throughout the western Cornbelt and how saturated the ground is here. What I'm going to do is play this through relatively quickly through Monday, Tuesday, Wednesday. We're now at the end of the week, Thursday, Friday. Now as we get into the weekend, this is Sunday, Monday, Tuesday. Now what you notice is that if I just play the weekend for you again, with the European model returning a lot of precipitation, possibly half of an inch to maybe over an inch of rainfall into this corridor, it's really bringing up the soil moisture values here. And that's what the probability is right now. It's about a 50 to 70% chance that we at least get 3/4 of an inch of rainfall from scattered storms in this area. Again, it's a place that needs it quite desperately. So we'll just keep an eye on this all week long to see if one model is more consistent with the other. And we'll kind of pick which one we think is going to be the more accurate with this system that's evolving here. Now, taking this out into day 10, I did start to notice we do end up getting some sort of blocking off the west coast. There seems to be a high over low pattern setting here. Quite bland flow across the United States, which pulls off into a ridge here over the east. But this is not a pattern that's going to bring in a lot of excessive heat here, but it's going to be more focused back to the west. I'll show you the temperatures in a few moments. But with that tropical system pushing in here slowly, and with the stalled out frontal boundary, you can see that the European model is just very aggressive on being above average in terms of precipitation for a large portion of the United States. Now, what about the GFS? Well, it has that same look. See, there's kind of a ridge here with a low to the south, so this is still there. The flow's still weak. There's a broader trough here, builds into a ridge off these. So you could look at this and see a lot of similarities overall, even with the strength of the trough that's off the Aleutian Islands, that's there. But the difference is in the precipitation patterns as over the parts of the south. This is consistent between the models, but the GFS down here across the Gulf Coast is drier in this region than the European. But other than that, they have a very similar picture looking out that far. Now let's talk temperatures, because we have a large area here in the west that's either looking at heat advisories, red flag warnings, heat watches, excessive heat warnings. We still also have down here heat advisories and air quality warnings as well. Those high temperatures today in Montana are very hot, and they're going to get hotter tomorrow. This is Tuesday. We're talking about upper 90s to lower hundreds in this area, maybe even approaching 110 in some places. East Coast remains cool throughout much of this, and you'll see that by Wednesday, getting into Thursday, this is when the ridge really starts to take shape west. We have in Central Valley of California, temperatures 106 to 117 down here pretty far to the south. And as we play forward, getting into Friday, Saturday, and Sunday, this is where the pattern really takes over with that larger ridge, and we drape the frontal boundary somewhere in here. And so with the moisture coming from the tropical system, cloud cover keeps it cooler there, and the potential for rain along this frontal boundary, that's why you see the cooler weather at that time period. Total evaporation this week could be very high in parts of Montana and throughout the entire high plains. And then it'll get much higher in the west, including the Columbia Basin, which could get their evaporation rates above about 2 inches in places through the next 7 days based upon this heat. And that's where the heat goes. As you look out there today, 5 through 10, what we see is most of the temperatures that are anywhere between 10 and 25 degrees above average at times will be confined to the west as the jet stream gets blocked a bit here in the Gulf of Alaska. Now the cooler conditions coming in here, I just want to make sure that we don't overstate the colors. It's just 3 or 4 degrees cooler than normal. All right, so this isn't really cold air that's coming into this region. And honestly, after some of the heat they've endured, this is going to feel good. Now from there, I wanted to take you out and show you the new European weeklies, because we're going to see, if you get my morning reports, you're going to see the newest version of these tomorrow morning when that data come out. But this is what they're looking at right now from June 21st to July 21st. We talked about last time why we thought this was a very likely scenario going into midsummer, but the models continue to keep parts of the northern plains, the Canadian prairie, extending into parts of the central plains drier. And there's going to be a boundary somewhere in here where it's going to be very tough to make a call in the longer term pattern. I'll also say this, the longer range models, when you look out there over that 30-day time period, do tend to keep much of the United States warm. So when these cooler shots come through, they're not lasting more than a couple of days. And what I think is going on here is this is the net effect of where the jet stream position is. We've pushed it north, and we keep flanking the United States with rather large ridges, which helps keep it farther to the north. but seeing that as the temperature and precipitation pattern from the European model. What I'd like to do is I want to talk about ocean temperatures in the MJO, then we'll wrap this up. Now the ocean temperature configuration, as we've been talking about it, still looks quite the same, but there have been some changes as of late we better discuss. And those changes look something like this. I'll start showing you this map more often, but it's the last 7 days of ocean temperature trends. And you can start to see some warming happening in this area. Now, does this type of warming really cause alarm in me to say, oh my gosh, the waters are warming up quickly, we need to abandon some of our earlier thought about what those waters are doing? It does not. It fluctuates quite a bit week on week. If we continue to see this trend lasting into the month of July, then it could change our mid and late summer pattern. And I expect something like that, but we'll watch it carefully to see what these kind of changes do. What I'm a bit more interested in right now, though, is what's going on over the Indian Ocean and then into the West Pacific, specifically with the MJO. Because when you look out here at the central United States National Weather Service region, and I reconstruct since 1948 the July and August temperature patterns, what we're looking for here is what made these years really, really hot versus some years that were quite cool. And if we can understand the differences in the flow pattern, that might help us understand what to be looking for in those ocean temperatures. Now, I've told you time and time again that those really cold ocean temperatures in this area tend to correspond to quite hot conditions in the central United States. So we've covered that extensively. But what about the weather events that move through this pattern, specifically the MJO? You see, when you look at the June weather patterns for those very hot July and August time periods, we tend to favor keeping the MJO somewhere over the Indian Ocean, be it from phase 1 all the way to phase 5. Okay? There tends to be a lot of subsidence over the Central Pacific. So those years where we had hot and dry July and August, the June pattern tended to favor an MJO that stayed away from this part of the Pacific Ocean. And why I bring that up is because right now, through the next 15 days, we're actually seeing that. There's a lot of subsidence in the atmosphere here. And there's some rising motion here, and this is part of the reason why we're going to be looking out for a tropical system in this area. But when you look at where the MJO is, what I'm trying to tell you is if the MJO goes over into these phases here, in other words, this side of the diagram, we're moving it into the places where during our hottest and driest years, it didn't go. So if we keep it, I'll just draw a line. If we keep it over here in the Indian Ocean or by Africa, this seems to be where the MJO spends a lot of its time, where good rising motion happens when there is risk of drought and heat in the midsection of the country. So the big question we're going to try to answer over the next just few days here is the temporary cool down, the stalled out boundary, just something passing through the flow where the larger controls are going to go back over to greater risk longer term with drought? Or are we seeing a systematic shift? I apologize, but I'm not ready to make that call just yet. I've got to see some more data and see how this week plays out. But I'll report back to you again on Thursday and each morning in my morning report. I appreciate your attention, and we'll talk to you soon. Thanks.